Hello, lovelies. We are on to chapter 4. Okay, let's talk about covalent bonds. We talked about ionic bonds. Ionic bonds have charges. Covalent bonds are sharing. Covalent bonds are formed by sharing. They are sharing bonds, sharing the bonds. So instead of, hey, you take one in my outer shell and I'll take two from your outer shell or something like that. Basically, they're just sharing. They're like, we both need one. I have an extra one. You need one. We're going to just share that together. A group of elements are held together by, and we're calling those bonds covalent bonds. Covalent bonds. So we are calling them covalent. So if I say it's covalent, you're going to know that it's a sharing type of bond. If I say it's ionic, you're going to know that it has a charge. And they're not sharing. One is just taking from another. Also, when I say it is a molecule is a group of atoms held together by, what kind of bonds do you think? By covalent bonds. Yes, so this is going to come up in a quiz. I'm going to give you a quiz probably on Monday just to make sure that you watch this. And I'm going to ask you what a molecule. I'm going to give you some kind of matching or somehow ask you the question that a molecule is a group of atoms held together by covalent bonds. So I'm going to ask you that. Write it down because it will be on the quiz. Okay, an ion. What is an ion? Ion is an electronically charged atom or group of atoms. So it's an ion. That's what we talked about last in chapter 3. It has a charge. Molecules are a group of atoms held together by covalent bonds, so it doesn't have a charge necessarily. We'll talk about that. I feel like I just tell you things and I lie to you. I don't lie to you on purpose, I swear. Okay, so what we're talking about here is basically 2 atoms, 1 oxygen. I got one for you. This is oxygen. These are hydrogens on the end. They are sharing. Oxygen is not taking these, they are sharing this. We will talk about why some atoms share and some atoms take from others, but this is water and it is sharing. This hydrogen is sharing its 1 and the oxygen is sharing the 2 that it needs. So again, what rules this mostly is the octet rule. The octet rule gives you most of what you want to know. With the main group elements, they undergo reactions that leave them with how many valence electrons? 8. Oh, we'll put it in red just so you know. 8. 8 valence electrons, or 2 for hydrogen because it's sort of special. So again, they all want to be noble gases. Everybody wants to be a noble gas. Nonmetals can achieve an electron octet by sharing the appropriate number of electrons in a covalent bond. So hydrogen can also share a bond with itself to form H2. Now, some elements do this. Diatomic elements. It doesn't sound like diabolical elements. It sounds slightly more cool than it actually is. No, diatomic elements are actually really very cool. Diatomic elements are things that are going to form homonuclear molecules. I'll put that in red in just a second. Molecules where all the atoms in the molecule are the same. The same. So they are all the same. So these guys here, there's 7 of them in your notes. Also probably going to be on some kind of quiz. These are the diatomic elements, right? They form bonds with themselves. They can't kind of like think of the dating game and it's like, oh, I can't find anybody else, but like I know this other oxygen doesn't really have anything going on, so I'm just going to form with another oxygen instead of like moving out of my group and trying to find somebody like way over in the halogens. I'm just going to form with myself. So we've created a subclass for these kind of elements because they're special. And they are called the diatomic elements. And there's 7 of them, and they are this. You can even, I would highlight them on your periodic table because I'm going to let you have the periodic table on the test. And I might ask you something about the diatomic elements, so it might be fun to highlight them on your super pretty periodic table that I gave you. You're going to want to like laminate this when you're done with the class because you're going to have so many fun things written on it. So you are going to want to put these down. These are the diatomic elements. They form with each other. The shape of electron orbitals allow prediction of, the shapes of electron orbitals allow prediction of molecular structure. Structure. So basically, when we know the shape of something, we can tell a lot about it by knowing the shape. Also, we can predict the shape because things like this, we know that it's bent. Two together would be straight like this. We'll talk a little bit about this in a minute, but basically, elements repel each other. They don't really like to be so close. They're that kind of people who are like, no, I want to be as far away from you as possible. So all of their shapes represent this, that they want to be as far away as possible. You would think that water would be straight across, but that doesn't actually work out, and I'll tell you why in a little while. So that's the suspense to get you to watch the next video. You want to know why hydrogen looks like this? I'll tell you. Okay, so moving on to covalent bonds and the periodic table, because you know how much I love the periodic table. Molecules. Now, a molecule doesn't have to be made up of just diatomic elements that form with each other. That's just free, fun information that some elements do that. They can be, and you'll see, they can be made up of different elements of different types. They can be made up of identical or unlike compounds. A molecular compound, again, I'm saying this a couple times, so you should get it by the time I'm done, is a compound. A compound that consists of molecules rather than ions. So it doesn't have a charge. In these compounds, each atom shares enough electrons to achieve what? A noble gas configuration. Okay, so that's what's going on there. And we'll just get rid of this one. There we go. Okay. The number of covalent bonds typically formed by the main group element gives you, again, 8 to achieve a full outer shell, which is kind of the same thing as saying noble gas, but I'm putting it twice. Full outer shell. You complete me. That's what chemistry was saying that before it was cool. You complete me. You fill my outer shell. Full outer shell. That's what we want in life. We want a full outer shell. It's what all elements are looking for in life, to fill the outer shell. Okay. So, number of valence electrons. Again, you can find this on your periodic table, which is why periodic tables are awesome, because they tell you all this fascinating information. You can write this on here if you can't figure it out from your periodic table, which would be weird because the number is right here. Sometimes you get the 3 or the 1, but basically it just tells you that from the periodic table, how many bonds you can form. But I put it in your notes just so you can double check with yourself. Okay, there's always exceptions to things, so I tell you stuff and then I tell you that I'm lying. Exceptions to the octet rule are boron. Weird. Boron has only 3 electrons to share and forms compounds with 6 electrons. Because it's boron and it just does that, and I don't know what to tell you. Elements in the 3rd row and below in the periodic table have vacant d orbitals. Yeah, the transition elements. And those vacant d orbitals can be used for bonding, which is why the transition elements are weird. But don't worry about it. The problems I'm going to give you are all going to probably come from the main group elements. And if not, you can use the other chart to look at the transition elements and see how many forms they bond. That's in the chapter 3 notes. So don't get too upset with that. Mostly I will use things that obey the octet rule. Okay, what helps predict the number of covalent bonds an atom can form? Guess what? It's my favorite thing. The periodic table. You should just get a t-shirt because it's so fun. You're gonna wanna wear it because it's so fun. The periodic table is what helps predict the number of covalent bonds an atom can form, just like it helps predict the number of ionic bonds. Same thing, we're just sharing instead of just taking things from people. In covalent bonds, each atom shares enough electrons to reach, here we go again, a noble gas configuration. Because everybody wants to be a noble gas. I mean, I feel like I've said this enough time. You should not miss on the test. I've said it like 10 times. Everybody wants to be a noble gas. You want to have your outer shell full. You want to form 8 in the outer shell. This should not be news to you. Okay, multiple covalent bonds. So you can form, you don't have to be a diatomic molecule. You can form bonds with other people. You can even share things with 2 people or 3 people. Some atoms form double or triple bonds. So in this way, you're forming a slightly stronger compound by bonding. You're sharing more than one electron with another. Like I have 2, you need 2, I'll share 2 with you. And we denote that and we call it a double bond. You can even share 3. I have 3 electrons that you need 3, I have 3, we're just share them. I'm not going to give them to you, you're not going to take them, we're going to share them. 3. So you can have a single, a double, or a triple bond. This is all kinds of fun because it lets us draw 2 lines. Super fun. Covalent bonds. Okay, let's define single, double bonds. This is really not that hard, people. The only way these molecules can have an outer shell electron that can have a noble gas configuration is they have to share more than 2 electrons, results in multiple covalent bonds. So a single bond, as you can guess from my earlier definition, is formed by 2 electrons. So this is just an electron from each side, electron. Double bonds. Okay, this gets tricky. You think it's going to be 2, but we already did 2, so it has to be more than 2. Formed by sharing. How many? 4 electrons. I cannot spell electrons. That is crazy. It's crazy. Oh, look, it wants me to make it electron. Okay. Formed by sharing 4 electrons or 2 pair. That's what we call it, double instead of a quad bond. We call it a double bond because it's sharing 2 pairs. But altogether, there's 4 electrons being shared. A triple bond formed, can anyone guess? Let's put it in red. Formed by sharing. Anyone? 6 electrons or 3 pair. Yes, there we go. Okay, ionic compounds. So this is just a review. What do ionic compounds have? Going back to chapter 3, high melting points. Remember? They also have high boiling points. Boiling points. Due to what? Due to attractive forces, electric forces. So they have negative and positive. So they are, they have high melting points and high boiling points because it takes a lot to break those bonds because it's an actual electric bringing together a negative and a positive. They're coming together. It's a strong force. So it raises their melting point and it increases their boiling point. So this is due to attractive forces between opposite charges. So this is important. So what is this? What do you think this is going to tell us about molecules? The opposite, right? Molecules are neutral. Yes, they are. Molecules are, they have other things. High melting points, molecular compounds should be written in there. Oh, it's different. Mine is switched around. Okay. Molecules are neutral, so no strong electrostatic attraction. What do you think that is going to have? How's that going to affect things? That is going to affect things by are usually non-polar, so they don't have a charge, and they're insoluble in water. I should also put up here high melting points, high boiling points, and soluble in water. Whoops, let's move the points back up here, sorry. High boiling points and soluble in water. Okay, so move that back up here. They're also soluble in water. They have high melting points, high boiling points, and they're soluble in water. So just by the opposite, molecular compounds are going to have really not changeable or lower melting points. They're not going to change their boiling points, and they are not polar. They are not non-polar, and they are not typically soluble in water. So how are they staying together, right? They're not really, they don't have this electrostatic attraction. So what on earth is keeping them together? What is keeping this thing going on? The thing is intermolecular forces. They're very weak forces, and they are called intermolecular forces. We are going to talk about that in the next video. Stay tuned. Very exciting stuff.